Alright, so this was the problem you had a question on. I would start by trying to make u equal sine x, and then I would say, okay, well, if u equals sine x, then du would be cosine x, and that isn't in the problem, so that doesn't work. And then I would say, what if I made u equal x cubed, but then you would need 3x squared in the problem because of du, and that's not there either. So then I would go to, how can I rearrange this problem so that it means something different? And I would remember that cosine squared plus sine squared equals 1. And this is part of the trig identities worksheet I gave you that you're going to have to do some practice on because you have to know those 3 Pythagorean identities. So that means that sine squared equals 1 minus cosine squared. So I could rewrite this as 1 minus cosine squared x times sine x dx, because again, this is sine squared. And sine squared times sine would give you your sine cubed. So then I would try to do u substitution using this expression. But the problem I would run into is if I let u equal this, then the derivative would be negative 2 cosine x sine x, which would give me an extra cosine in here. It would take care of that sine, but I would still have an extra cosine. So then I would say, what else can I do? Even if I make u be sine x, then du would be cosine x, but this is cosine squared. So nothing looks good. So then what I would do is say, okay, I have a binomial times a monomial. Maybe if I distribute, that will help. So I would get sine x minus sine x cosine squared x dx. Now this is starting to look a little bit better because we know that when you integrate a difference, you can just do the integral of the of each term. So now we have, why can't I erase anything? This is a different program than I'm used to using, so I'll just go to the next slide. Maybe. How about add a new slide? Okay, so right now we have the integral of sine x dx minus the integral of sine x cosine squared x dx. So this one's easy. Integral of sine is negative cosine, right? Because derivative of cosine is negative sine, so the derivative of negative cosine would be sine. Yep. Minus, now for this one, I would let u equal cosine x. So where can I write that? U equals cosine x. So du is negative sine x dx. So all I'm missing is the negative. So I would do, I'm going to take this expression right here and integrate it down here. So I would have the integral of u squared du, but I would need a negative outside, so then I have to put a negative inside. So negative integral of negative u squared du, because du is negative sine x dx. So sine x dx, and then I put a negative, and now I'm good. To integrate negative u squared, I would do negative, this negative right here is this negative. And then u squared would be 1/3 u to the third, but I need a negative. And it would be negative u squared. Okay. So when I plug back in, the negatives cancel out. So I just have 1/3 cosine to the third x. So let me erase all of this nastiness. Why can't I erase? I don't understand. Oh geez, that's why. 1/3 cosine cubed x. So right now I have This is taking forever. Oh, I have the integral of sine x dx minus the integral of sine x cosine squared x dx. And we said this was negative cosine x. And then there's a minus here. But then everything that I simplified when I did that, back on this, apparently I can't go backwards. But this whole thing, ignoring this minus sign, this whole integral simplified into positive 1/3 cosine cubed. So we're going to keep that minus sign there and do cosine cubed x over 3 plus c. Now again, I don't know where the original problem is. I don't have my book at home. But check and see if that's the right answer. That's my best guess for that one. It's not a guess. It makes a lot of sense. So then you asked me something about secant squared. And I would tell you that there is also a Pythagorean identity with secant squared. It involves tangent squared. I think it's something like tangent squared plus 1 equals secant squared. Let's see if that's true. So tangent squared would be sine squared x over cosine squared x, plus 1 would be cosine squared x over cosine squared x. And when I add those together, I get sine squared plus cosine squared all over cosine squared. This is 1. 1 over cosine squared is secant squared, so that's true. So tangent squared x plus 1 equals secant squared x. So when you asked me to integrate secant squared x, I think that was one of the questions you had. You said the integral of secant squared x dx. I would rewrite it as the integral of 1 plus tangent squared x dx. And then I would do the integral of 1 plus the integral of tangent squared x dx. And the integral of tangent squared is, I don't know, negative secant squared maybe? You have to look at that list. But I'm pretty sure some trig function has a derivative of tangent squared. So that's how you would do that one. Okay, hope that helps.